since I will be doing some code that wow, that's great, man. That's really great, man. Yeah, that's awesome. I don't know. Yeah, that's totally awesome, man. Seems like you are on the right track. Yeah. You're a big boy now, making a lot of money. I always forgot transform stuff. You must be on the right track in terms of your project then. Yeah, is that much or is it not much? Let's see. Yeah, so it's not much for you, or is it a lot of money? Yeah, it seems fine. Who doesn't love kebab? So this is supposed to, whenever we press F1, this is supposed to go into the renderer. And since we have the preloading of static objects implemented, I think I'll allow some kind of submission to the renderer. Uh, and we will pass in just the game object reference and the object transform reference. And as in our static object creation, we need to create some information. I'm just gonna copy some of it. We're not gonna iterate over anything here. All right, so we start off by trying to create a render item for the renderer, which will have the object ID of whatever we pass in. It will also have the material. We will have to fetch our mesh information though, and that will not be stored in here. Maybe we pass in a reference to the meshes, but we could do internal lookups. I think it would be faster and more efficient probably just to pass in the meshes as well. Let's do a reference to the vector of meshes. Game meshes. Let's see. We also need to, of course, copy that parameter inside the method. And now we can just fetch the mesh ID. And then we get the rendering item data. And let's see, we pass in the transform, and we want to, instead of we do not iterate over them, we have an internal one where we want to grab the last one, and or rather maybe we just want to get the size of this, since we end up increasing the size, and since the size is always one bigger than the actual index, this should probably work. And let's see if we do size -1, and instead of that the object doesn't have any transform information. Well, it's because it's not supposed to be like that. It's like that. Yeah. All right. Let's see. Let's just do the same thing here. So this code should allow us to create a new render item given the mesh information and the transform information. And I will just add a temporary testing variables. Bool has been run. If it hasn't been run before, we would like to run this code and set the flag to true, so we only do it once. All right. Now we can do some testing of this code. Now we can do some testing of this code. So if we ask the renderer to submit an object, which will have the mesh of 0, so it will just be a box. And it will have our second material. We want to give it the transform and the vector of meshes. Does everything compile? Yeah. All right. So whenever we press F1, if everything works correctly and we don't have any crashes, we should spawn a box in the middle of the scene at yeah, actually down below here, but let's just test it out. All right, we do have some subscripting errors, but that was to be expected. So let's just step through this code, and we press F1 and get into the loop. Our object temp 5, and just let's look at our game objects. The last one has an ID of 4, so that's correct. The mesh is 0. Yeah, and the transform. Oh, well. Now we of course add it to the list of, or rather, vector of objects. There we go. So did it work? Yeah, it worked. Oh, you can of course not see it happening, but so yeah. Whenever we press F1, a box should spawn here, and it does. Great. That means that we can now spawn objects. We cannot delete objects, but that is something for a different day. I would like to spawn it above the game scene, since it's supposed to be animated and be falling down whenever I start the simulation of it. But right now we have no way of simulating anything. Yeah. So now we need to create a new system that actually handles simulations. We can always elaborate on the system and refactor it, but yeah, I'm gonna do some more temporary code here. But if we start building a so-called physics system, and implementing that into our application. We will start by doing some sort of basic temporary system, since this will not be a full-blown physics system for a start. We just want to actually simulate something moving in our game world. We would like to, whenever we spawn the box like that, we would like for it to fall down, and by that we need to manipulate the data structure that we already created for the object. So our data structures are like this. We have materials and meshes. These are not going to be changed, but we have objects which can be marked as dirty, meaning that the renderer or other systems are supposed to recalculate or rather update internally whatever needs to be updated. For now, we mark an entire object as dirty whenever we do changes to it. We also have the object transform, which handles the location, scaling, and rotation of the actual game object in terms of the renderer. Meaning that if we do some sort of simulation where delta time is applied for smooth motion, and the object transform is updated outside the renderer, but or rather the original object transform is updated / moved with respect to delta time, and then the object is marked dirty. The object is object vector is processed. Dirty objects are collected. A vector of dirty objects are passed to the renderer. The renderer is it the renderer? I don't know how it's supposed to be actually spelled. Anyway, the renderer then updates its buffers according to the movement. And we end up with the result of the object moving not only in data but also visually. So yeah, we want to start a simulation that is supposed to run for each iteration of the update loop. We're gonna do all this logic before actually we do any render updating. Let's see. It's not supposed to be in this part of the update loop eventually, but for now we only have an application. We do not have a world sort of container / object, so we will do it like that. Yeah, so here we would like to do simulation we already have a update pass, so it's simply just um, adding two references to two lists, which is the pre-processed dirty objects. Yeah, so let's do some temporary stuff over here. Let's do a gravity uh, simulation. Let's just close all this stuff because we do not need it for now. And we do it in our namespace. And we also make the namespace here. All right. Now we have to just close some of these tabs because they are not needed. I'm just gonna update the titles of the stream. There we go. So yeah, we want our gravity simulation to be part of our application. Whoops. And you might see why I want to move a lot of these things that I already commented into a storage of sorts. World, scene, object, container. It's probably going to be a simple object. I'm not really into storing a lot of information on the specific API objects. As I've mentioned, it will end up being a data-driven structure that underlies the physics and some parts of the renderer. So yeah, but we have to start somewhere. So now we are able to add a system. This is on par with the renderer. Let's see. Simulation and drawing. This is helper systems. Let's do a gravity sim. Gravity. Let's just call it simulation, since we don't mind. Just replacing it with a more complex structure, but we will have, of course, a default constructor because we don't care that we can create an empty object. And then we would like something like a update method, or rather maybe just, are we supposed to, maybe we would just want to call simulate. Let's see. So maybe we want to actually separate static and dynamic objects, because we're not doing simulations on our Well, no, let's just build a specific list of let's just do we would like to do simulations on specific objects. Right now we only do it on one object. Maybe we should just start by doing one object. Let's just include game object data. Yeah. We need to take in the float of delta time. We want to pass in a game object, and then a transform of sorts. What did I call it? Object transform. Transform, and I of course have to move the reference tag here. There we go. And we do not need a constructor. And we of course need to, not the renderer, in the application, pass in our delta time, meaning our time step here. We will then, let's see, let me just check something out here. Let's just see. Never mind. I'm just gonna do this simulation. I'm gonna pass in the latest added object. I'm only gonna do it if this has been run, since right now this is somewhat intertwined. It's really not so how it's supposed to be, but right now we just implement something to get an overall structure, and then we redefine whatever we have to redefine. So now if we have created the object, we pass it into the simulation along with its transform, and we pass by reference, so we can alter the simulation. First off, we set the object to dirty. we then apply a matrix translation force add let's see, some basic physics, gravity, force formula. Let's see. Game, let's just do that. Okay, we got a formula game. So the acceleration is the let's see. Anyway, let's just do a translation matrix, which will do be set to a math get identity matrix. I'm unsure whether this compiles. I think. Huh? Yeah, we need to add that. I think. There we go. Yeah. So it does include that. Since we're applying force, a simple force here, we will just take the y-axis and let's see, since this apply a I mean the first one is supposed to be, yeah, and then delta time times whatever positive y is downwards. So let's just do maybe like that, and then we translate the transform, meaning that transform.transform is supposed to be transform.transform times force. Now we should see our transform information changing. So if we set up a breakpoint here, let's just do some random values here to allow us to get a finer step. Into before and after. So we press F1, we spawn our object. Well, we can't see it during the break. So yeah, Right now we have our object, game object, which has no dirty flag. We also have the transform, which has we're applying it to the first row in particular, or rather column in particular, or rather second column, I'm sorry. Yeah, so let's do a step. Nothing's changed. And let's try to remember these values. All right. We actually took a rather huge step, it seems, and this is true. Yeah, it really changed the whole. It didn't change these, but it did change the. Yeah, let's see. Let's see that again. So before the transform of this object had values like that, and then it gets changed. Yeah, but I definitely think that it's too much of a force that is applied. Maybe we can check it out again. Let's see. It's not dirty yet, so it hasn't been changed. Let's just check if it updates anything else. It's probably not gonna do that. It gets fairly small. Okay, maybe I'm not doing this correctly. Let's see, so negative is up. We want to add something to this. Yeah, maybe we want to add it. Since the transform, yeah, adding to it seems more right? Whenever we, yeah. And I do not have an operator for the plus yet. It should probably be fairly simple. Anyway, we would like to translate it. I'm not sure that multiplying it is the correct way. Yeah, since the transform holds the translation itself. Yeah, if we wanted to double the, yeah, I'm doing that wrong. All right, let's see. In terms of math, let's do some operators for that. Let's do a G matrix vector call operator plus between another reference to a matrix and this one. Let's see. There we go. We have not implemented it there. And we do it outside the math scope, so this is gonna be the plus operator. Right now this should make that work, but it's not correct. Let's do a let's do matrix add and do two references. Yeah, you could do it, but then you couldn't do it by const. Yeah. I'm unsure whether I want one way or the other, but let's just do two separate references here. And for now, just return the G matrix constructor. And then let's do some Intel intrinsics. And let's do some adding. Let's try it. Yeah, so we basically just do a G matrix result, and let's say result d0 is equal to let's see, do we have other versions of the new so green, we have dark green and blue, add round. Nope. Let's just do or rather add or rather 2. Yeah, let's just add our matrices together using intrinsics. And return the result. Yeah. Yeah, we would actually actually like to step into this since it's somewhat easier, I think. Let's see, our transform. Does it change? We're especially looking at this particular line. Yeah, so we do something. Let's just add one for testing purposes. Well, wait a minute. There's a reason why I do multiplication, because the other factors are not supposed to change. So I do think that, let's see, let's just half it. I think multiplication is actually the correct thing to do, because if we add them, the parts of the ident will, or rather the other parts of the transform will also be affected. So let's see. Ten times a half. Let's do maybe times -1. We do yeah, I think we need to change our logic here, but -1. Well, let's try -0.5. So it went to 1, as we saw. But what does it go to now? -0.5, so it got smaller. So we need a bigger value, maybe -15. Let's try that. Just our transform here. Yeah, -15. Let's add it. It was definitely the wrong direction, because yeah, so 15, but it went 25 units, so maybe we just want this to be a fairly small positive value. Let's see. One point two. It jumped a far, pretty far. Hmm. Something is not correct here. I think I'm doing it wrong. Yeah. I think I'm doing it wrong. Let's just see. Let me find a regular formula. Gravity delta time game. Maybe I do want to add it anyway. Yeah, okay. Okay, now I know. We're not supposed to do a identity matrix. We're supposed to add the force, of course. Like that. Yeah, I don't know why I ended up doing that. Doesn't make any sense. Now this should work. Because I can just stop doing an identity matrix. Yeah. Let's see. We end up here again, and this time but we're moving really, really far, it seems. Let's see. So, oh, whoops, this is not supposed to change as well. Let's see. We step into the simulation. Does this get smaller or 42? Huh. Let's just see the force object. Does it contain garbage values? Yeah, it does. That is why nothing is working. Let's see, 0. Or rather just search for 0, find our type, mask, and node. What is the intrinsic? I can't remember it. I'll just look in our code. We have it somewhere. I think it's one of the first functions. Set 0 PS. There we go. There we go. And our transform here. it changes this value. Huh? It replaces the old one. It's not supposed to do that, right? I don't know why it would do that. It's not supposed to set that to 0 or that one to 0. Maybe our addition is flawed. Maybe I just return an empty vector matrix. Maybe I forgot to change the. Let's see. Oh well. It's because I haven't changed the operator. We're basically doing multiplications every time. That is why nothing is working as intended. Okay. I forgot that one. Let's see. Let's see. Maybe it's such a low value that nothing actually happens. Let's try to change this a bit again. It's probably outside the bit where it gets included. Let's see. It just gets truncated, I guess. Yeah. All right. Now we do reduce the position. Huh? Let's check it out. All right. So each frame, it does a fairly large step downwards. Let's just maybe take 100th of that. It's of course dependent on delta time, meaning that whenever we do steps here, it will probably not be adjusting correctly, which is also why the delta time for the yeah. Anyway, right now we do have some simulation. We can always adjust our simulation. Then we would like to create a vector of game objects, dirty objects, and to our dirty objects we will add a copy of this object. And we will update the transform data. Let's see. Am I supposed to? Yeah, I'm supposed to pass in both the transform data and the game object that we want to update. But I'm gonna have a short bathroom break. Yeah, so I'll be back in a short while. All right. Let's see. So yeah, I'll be implementing the last parts of this sort of animation thing. Yeah. Uh, and then I'll be having a bit of a longer break since I've been going at it for several hours now. Um, yeah, so in our update method, we want our pass data, we want our game objects. Right now we just copy them, which isn't uh, fairly very efficient, but yeah, we will do it like that. We will pass in references to our objects, and let's see. Okay, what am I doing? That is not where I was supposed to paste that in. Let's see, like that, and we would like to pass in the dirty objects, or rather, uh, let's see. We will do something here that is not great because this might end up giving us a lot of problems eventually. God damn it. Yeah, maybe we have to do shared pointers of sorts, even though. Yeah, okay. And it's because we want to reference the original objects and set the flag to not dirty, meaning that we would like to compile a series of pointers to objects. Right now we can just pass in all object transforms, but maybe we would want to compile that as well. Let's just try this out for now. I'm not sure it's supposed to be that way eventually, so we compile two lists of pointers. This might not be a great way to do things. It will pass a reference, which is a pointer. So let's just do object transform pointers dirty transforms, and right now we do it for the last object. There we go. Does this compile? No. Let's see. I think Isn't that supposed to actually work? Maybe if I do references. If I do like that. This is probably not gonna work. No. Let's do pass in a pointer for now. And we would still like a reference to the structure. It's something in terms of the vector interface. Let's see. We do get a reference to an object, but let's see. Failed. If I reference the, I'm not sure whether it needs a parenthesis. Maybe if I do something like a game object pointer, geo pointer, we can add that. Pointer. That should be fine right now. And if we don't do this, do we still have an error? No, we do not. So this is we're not allowed to yeah, we're not allowed to for some reason we're not allowed to store a vector of pointers even though it's highly unsafe. Uh, uh, so it's something in terms of the way the implicit conversions are stored. Am I allowed to store void pointers? I know this is gonna be really hacky. Am I allowed to do that? I actually am. Yeah, maybe it's because it's structs. It's storing vector of pointers to structs, compiler error. Let's see, pushback. And let's change this. Because this shouldn't call the constructor. Let's see. Huh? Let's just see, pushback. This actually compiles. Oh my god. I'm so freaking stupid. Maybe It did work after all. I only got one error. Yeah, I'm so freaking stupid. I've been working too long without a break, so yeah, I definitely need one. Um, let's just do these, and then move these into here. And then we need to update our stuff. Then for each object in game objects, we would like to right now we wait for each frame, so we shouldn't run into problems by updating the constant buffer. Otherwise, we would need a checking system during the yeah, we would need a checking system before we actually update the constant buffers. Otherwise, we might run into trouble. So for each game object, we end up by setting the dirty flag to false. We would like to fetch the ID. Let's see, for each internal object transform, does it contain? No, actually, our game objects do not store the transform. But we can find the transform itself. This is gonna be some hacky code that we will need to revise whenever the system allows you to delete objects. So yeah, but for now this will work. Or rather, this isn't good. This isn't good. Let's just see. How do I allocate the resources up here? Ah, yeah, okay. The render item stuff. Actually, okay. I did actually implement something that can if render items dot ri dot object ID is equal to the object Let's do index equal -1 object ID. Index equals RI, and then we break because we found the index of the update object that needs updating. And maybe we actually want to be able to specify pairwise operations there, so maybe we want an integer of go to be like that, and while go is less than the size of this, we increase the go. Instead of that, we do game objects go. Yeah, and then we found our index. We can then check if the index is above or equal to 0. And we do our updating. Let's see, rendering item index dot transform index, and we step into our transform. What is it called? Object transform constant buffers, and we do a get memory to get the void pointer, and we copy the memory from object transforms for game object transform, the address of that, and we do it in terms of the transform object data. Yeah. This will probably not work, but at least it's something to the effect of that. Let's see. Oh, I thought we had a crash. We are actually moving. It seems, at least. Let's try to increase that by the speed of 100. Yeah, we're moving. We are moving. All right. We are not moving very fast, but we are moving. That is pretty awesome. So let's say we initialize it a bit down the x-axis instead. Let's just do 4 points off the x-axis so it doesn't collide with our lights. There we go. And right now it syncs through our floor because yeah, we do not have any checking in terms of whether it collides, but yeah, we can change this algorithm to sort of just get the result of the plussing of the specific vector. Actually, we could simplify this by just doing this code instead. Let's do a G vector force and delete all this old stuff, and we just do add ps. Let's just do this and the force, and that is probably fine still. Yeah, everything works fine. And then we just grab our mask, let's see, let's do a float min y equal to, I don't know, let's do, yeah, maybe a 4 for now. So we want to restrict the negative y. So that it cannot be less than that. Do we have something called less? Compare set it to 1, or otherwise we set it to 0. If a is less than or equal to 0, let's just do the vector min y is supposed to be just, we don't really care about the first 3 parts of the vector. We just want to get a vector diff, which we do by do the compare. Oh, it's not like that. Compare equal less than compare less than equal, and whenever the position maybe we just want to store it in force. If force the last component of force is less than min y, we could change this, since I'm not sure intrinsics are that much faster. Maybe they are. Yeah, let's just check this out. And the difference yeah, let's see, the difference is still not 0. Alright, let's just increase the force of this by a lot. Let's just check that everything works. Yeah, let's just increase it even more so that it steps through the floor immediately. Yeah, let's just increase the step and then step into this. The difference is not yet anything. Let's see. We do it again. The difference is not yet there. Let's see. Well, I'm pretty sure we are supposed to have a value. I mean, let's test it out again. Or transform. No, it's not the force. The force is like that. Min y. The difference is min y. So the first time it goes into this part of the simulation, it's not gonna be smaller than, so since negative, it is gonna be smaller. We're using the wrong function, I think. Uh, uh, less than, higher, or equals. Can I do that? Uh, let's do compare. Greater than. There we go. Let's see if this last component here is greater than, since we have positive values, thereby we set it to not a number. Yeah, I think there's a way to do some comparisons. Maybe I'm just making things work worse on myself. Uh, if we mask off, yeah, you could do masking. You could do different. Let's just delete this, delete this. And just do some simple load the PS1 load. It's just the first one. In reverse order. That sounds great. So we have a float last digit of 4, which gets initialized as 0. And we want to load wait a minute. No. It is store, isn't it? Yeah. Store PS1, the lower. Can I store the upper? Store reverse, maybe? Yeah. So store reverse into the last digits, and we store the force. Use the force if last digit 0 is above. Let's see, 4.0. We do one thing, otherwise we apply the force. Equal to, let's see, we don't do any updating at least. And we would like to set it to we would like to set the last component of the I'm not allowed to access the register like this, right? No, I'm not allowed to. Let's see, maybe I'm allowed to set the register like that. I'm not sure this will actually work. It does. Could I even do comparisons? Whoops. Am I allowed to do that? All right. We could actually just do that then. I'm not sure whether this is somewhat janky. I mean, accessing the memory register is probably faster, but I don't know if it's nice to do in terms of good practice. Let's just maybe we do end up, yeah. So now we can decrease our force here. Let's just do 1.5 maybe. No, that's way too slow. Let's do 4.0. Let's do 8. And there we go. There we go. Now this is not doing collision detections, it's just forcing the object to be no further down than our plane here. But yeah, it actually works. Great. As I've mentioned, I will be doing a short break. Yeah, since I've been going at it for quite some time. Yeah, hopefully you found some of this helpful. If you did, feel free to comment, like, or subscribe, or even follow here on Twitch. Hopefully I'll be seeing you around. Oh, that's the old roadmap. So yeah, we will look into where we got to on the roadmap in the next episode. But yeah, thanks for tuning in. I'll be seeing you around, maybe later today.